Hi students, welcome to Veteach. In this video, I would like to explain elements of a closed loop control system. In the previous video, I explained you the differences between open loop control system and a closed loop control system. In this video, we are going to know what are the components of a closed loop system or simply a control system. So the elements are input, output. Input and output are not the elements of a control system, but they are considered as elements of control system. And major and foremost thing important in a control system is the process or plant. This process or plant is the component of the control system which is to be controlled. So feedback and signal, comparator and controller. So comparator is a device that compares two signals. Controller is the device that controls the process. Controller is the component that controls the process. So now we see how a control system is represented with the help of a picture. So control system is represented with the help of a block diagram. Now we see what is meant by a block diagram. A block diagram is pictorial representation of the functions that are performed by each component and gives the flow of signals. A control system, as I told, control system is a system is interconnection of different components. The components that are present in a system will perform different functions, so that those systems are interconnected. Those interconnections can be represented with the help of a picture. The picture is a rectangular box. This box we call it as a block. Each component is represented with the help of a block. So a diagram that contains these blocks is known as a block diagram of a control system. Now we see the block diagram representation of open loop system. In an open loop system, we know that there exists process or plant is nothing but an activity that is to be controlled, which is to be supplied with certain number of inputs and certain number of outputs. So here these blue colored lines are known as signals. So signals in control system are represented with the help of arrow-headed lines. Suppose if the arrowhead is towards the plant, then that signal is known as input, and if the arrowhead is away from the block is known as output. We see the example for an open loop control system. For this open loop control system, I have taken automobile as an example. You take any two-wheeler or four-wheeler. You have started the engine, and what happens? The moment you started the engine, the vehicle does not. Suppose that you are applied the brakes and you are increasing the accelerator. Then what happens? The engine speed increases. The accelerator is represented with the or identified with the throttle angle. It is nothing but which control the fuel. In load torque is nothing but the amount of load that you put on the vehicle. So if you release the brake, the vehicle will move with certain amount of speed. The amount of speed what you obtain is directly proportional to the throttle angle. So this is an example for open loop control system. We see how a closed loop control system can be represented with the help of a block diagram. In a closed loop control system, some part of the input some part of the output is given as input to the control system. So in the block diagram, if you see, this is the input signal, and it is the controller, and this is the process that is to be regulated or controlled, which gives certain kind of output. So this output is feed back as input to the system through some feedback mechanism. This is called as a closed loop control system, and the closed loop control system is represented like in this manner with the help of a block diagram. As I told you here, in the elements of closed loop control system, I told you about the feedback. The feedback means the part of output that is given as input to the system is known as feedback. A closed loop control system is also known as a feedback control system. Another name for closed loop control system is feedback control system. So now we see the example for a closed loop system. Here I consider the same automobile as my example for this closed loop control system. You imagine that you are driving an automobile and you want to run this automobile at one particular speed, that is at a constant speed. I consider that speed as the desired speed. You know that every automobile will have one meter that reads the speed, that is nothing but the odometer, and the odometer reading is my actual speed. So I am there in the driver position, or you are there in the driver position. You are controlling the accelerator of the vehicle so that this automobile speed is going to change. Here we take an example. I want to run my vehicle at a desired speed of 40 kilometers per hour. Pushing the accelerator and the speed increases, and in the odometer the reading goes to 40. And as you apply pressure on the accelerator, the speed increases to 50 in the next instant. Now here this is the comparator. The job of this comparator is to compare these two signals. My desired speed is 40, but the actual speed is 50. Now the difference between the desired value and the actual value is known as error. My error is minus 10 kilometer per hour. That means I am moving little bit faster than what I supposed to move. Then what I do? I release, I reduce the pressure applied on accelerator so that the vehicle slows down. You imagine that the next moment speed goes to 30 kilometers per hour, so that the odometer will read a reading of 30 kilometers per hour. Now the error is 40 minus 30 is equal to 10 kilometers per hour. That means I am moving little bit slower. What I do? I apply pressure on the accelerator. Then automatically the speed of the automobile will picks up and reaches a speed 40. So I apply a constant pressure on the accelerator so that the vehicle will move at constant speed. This is what one of the example for closed loop control system in general sense. Now we see the same example in the system point of view. WR is the reference speed. It is the reference speed is the speed or the speed with which I want to run my vehicle. So this is the error detector is nothing but comparator. Purpose of using comparator in a control system is to compare two signals, two or more signals, and it is the controller. In the controller is nothing but the pressure what you are applying on the accelerator in the previous case, and a TL is the number of people those who are sitting in the vehicle. As the load torque is more, you know that the speed falls down. So that even though the number of this TL is, you suppose that TL is equal to 0, there is no load torque. Even then also it is possible to run the automobile at a desired speed. So that W is the actual speed of the automobile. So that the speed is given to a device what we call it as a speed transducer. So that This transducer will reduce or will convert the speed into an electronic signal, so that this comparator is an electronic circuit that was made with operation amplifiers, and the reference speed is also an electronic speed. The comparator will generate the error. Based upon the error, the controller will take its control action. What the controller will take? When the speed is higher, it reduces the accelerator pressure, and if the speed is low or error is positive, then the accelerator pressure on the accelerator will get increased. Like that, the control action can be achieved.